let's examine the iodine-131. The iodine. The iodine-131 isotope is commonly used in medical practice to check for thyroid diseases and malfunctions. Suppose a patient ingests 700 micrograms of this iodine isotope. Assuming that the half-life of iodine-131 is 8.0233 days, calculate in Part A the activity or the rate of decay of iodine-131 immediately following ingestion, and in Part B the number of atoms and grams of this isotope that remains in the body after 30 days since initial ingestion. So let's begin with Part A. So to calculate the activity, we have to use this equation to calculate what uppercase R is. So to calculate uppercase R, we have to know alpha, the decay constant, as well as N naught, which represents the initial amount or number of our isotope atoms. So basically, to calculate N naught, we have to use this equation. So we take the initial sample in grams and divide that by the atomic mass of iodine-131, and that gives us the number of moles. We calculate the number of moles by Avogadro's number, and that gives us the number of atoms of our isotope of iodine-131. So the mass of the sample in grams is given by 7.0 times 10 to negative 4. So we divide this many grams by the atomic mass of iodine, so 131 grams per mole, and we get the number of moles. We multiply that by Avogadro's, the moles cancel, and we're left with 3.22 times 10 to the 18 atoms. So basically, initially, the patient ingests this many atoms of iodine-131. Now, so we know what N naught is, but we still don't know what our alpha is. To calculate alpha, we have to use the relationship between the half-life and alpha of our isotope. So our half-life and our alpha basically are related by this equation. So alpha is equal to natural log of 2 divided by our half-life. So we take 8.0233, we plug that into our denominator, and we get 0.0864 days to the negative 1. So now that we know what our alpha is and N naught, we can calculate R. So because we're examining the activity immediately upon ingestion, our T is equal to 0. So we plug in 0 for T, and we see that alpha multiplied by N naught. So this quantity multiplied by this gives us 2.78 times 10 to the 17 atoms per day. So this is the number of atoms that decay per day immediately when the person ingests that isotope. Now, let's move on to Part B. Now we want to calculate the number of atoms and the amount in grams of iodine-131 that remains in the body after 30 days. So basically, to calculate the number of atoms, we have to use the radioactive decay law given by this equation. So the number of atoms N at some time is given by this equation, where N naught is simply this quantity we found in Part A. So 3.22 times 10 to the 18 atoms multiplied by E to the negative alpha, so negative this multiplied by 30 days, and we get 2.41 times 10 to the 17 atoms. So now we can use this to calculate what amount in grams we are left with. So the mass is given by taking the number of atoms and dividing that by Avogadro's number and multiplying that by the atomic mass of I. So basically, the number of atoms was found in this section. So we take this, divide this by Avogadro's number, and multiply that by the atomic mass. and we get 5.24 times 10 to negative 5 grams, or equivalently 52.4 micrograms. So this represents about 7.5% of the initial quantity of 700 micrograms that was ingested 30 days prior to this time period.